Humans feel the need for speed without a doubt. From the first time we sit behind the wheel, to choosing which roller coasters we prioritize at Magic Mountain, speed is always a primary factor. But where most of us have to stop our finding for a speed rush, when the Escape from Krypton ride ends, others get to go out and design objects and vehicles that go far faster than we can imagine. In this video, we will discuss top 7 fastest man-made objects in the whole world. Let's get started. Number 7. New Horizons. Maximum speed, 83,000 kilometers per hour. Launched by NASA in 2006, it shot directly to a solar system escape velocity. This consisted of an Earth relative launch of 16.26 kilometers a second, that's about 36,000 miles per hour, plus a velocity component from Earth's orbital motion, which is 30 kilometers per second tangential to the orbital path. Altogether, this set New Horizons barreling off into the solar system, with an impressive heliocentric speed of almost 45 kilometers per second, or 100,000 miles per hour. New Horizons is the first mission to the Kuiper Belt, a gigantic zone of icy bodies and mysterious small objects orbiting beyond Neptune. The sun's pull is relentless though, so sometimes you need a helping hand. In 2007, New Horizons had slowed to about 19 kilometers per second, and made a flyby of Jupiter to snag a gravity assist, where the spacecraft stole a tiny bit of Jupiter's momentum, in order to regain about 4 kilometers per second, before settling in for the long coast outwards. Number 6. Pioneer 10. Maximum speed, 132,000 kilometers per hour. Pioneer 10 was launched on March 2, 1972, on top of an Atlas Centaur launch vehicle. The launch marked the first use of the Atlas Centaur as a 3-stage launch vehicle. The third stage was required to rocket Pioneer 10 to the speed of 51,810 kilometers per hour, needed for the flight to Jupiter. This made Pioneer the fastest man-made object to leave the Earth fast enough to pass the Moon in 11 hours, and to cross the Mars orbit about 80 million kilometers away, in just 12 weeks. On July 15, 1972, Pioneer entered the asteroid belt, a donut-shaped area which measures some 280 million kilometers wide and 80 million kilometers thick. The material in the belts travels at speed about 20 kilometers per sec, and ranges in size from dust particles to rock chunks as big as Alaska. After safely traversing the asteroid belt, Pioneer 10 headed toward Jupiter. Accelerated by the massive giant to a speed of 132,000 kilometers per hour, Pioneer 10 passed by Jupiter within 130,354 kilometers of the cloud tops on December 3, 1973. During the passage by Jupiter, Pioneer 10 obtained the first close-up images of the planet, charted Jupiter's intense radiation belts, located the planet's magnetic field, and discovered that Jupiter is predominantly a liquid planet. Number 5. Galileo Probe. Maximum speed, 173,800 kilometers per hour. Galileo is a NASA spacecraft mission to Jupiter, launched on October 18, 1989, and designed to study the planet's atmosphere, satellites, and surrounding magnetosphere for 2 years starting in December 1995. It was named for the Italian Renaissance scientist, who discovered Jupiter's major moons in 1610 with the first astronomical telescope. This mission will be the first to make direct measurements from an instrumented probe within Jupiter's atmosphere, and the first to conduct long-term observations of the planet, and its magnetosphere and satellites from orbit around Jupiter. It is already the first to encounter an asteroid, and to photograph an asteroid's moon. Galileo used planetary gravitational fields as auxiliary propulsion stages, employing a well-tried technique used by Voyager, and some other previous interplanetary missions. The spacecraft dipped into the gravitational fields of Venus, closest approach on February 10, in 1990, and Earth to pick up enough velocity to get to Jupiter. This 38-month Venus to Earth gravity assist phase ended, with the second Earth flyby on December 8, 1992. It provided, in addition to the velocity increment, opportunities for useful scientific observations, and an exercise of the spacecraft's scientific capabilities. Number 4. An Iron Manhole cover, maximum speed, 201,150 km per hour. In 1957, the Nevada test site saw a series of nuclear explosions, that according to legend launched a manhole cover into space. Except it probably didn't. Here's where the story came from, and why the inadvertent source of the story has been trying to stop its spread for years. During a nuclear bomb test, called Operation Plumbog, Robert Brownlee was tasked with designing a test, for limiting nuclear fallout from an underground explosion. A device was placed in a deep pit, capped with a 4-inch iron manhole. Obviously, the cap popped right off during the explosion, but Brownlee wanted to test the velocity of the expulsed cap. The test was filmed using a camera that captured 1 image per millisecond, and only one frame captured the iron cap. Brownlee calculated its velocity at 125,000 miles per hour, which is 201,150 kilometers per hour, and that it likely reached space, but no one knows for sure. Number 3. Helios B Spacecraft, maximum speed, 252,800 km per hour. In April of 1976, the German-American Helios 2 probe made spaceflight's closest ever solar approach, cruising within 26.55 million miles, and 42.73 million kilometers of the Sun. Helios 2 also set the mark back then for fastest speed relative to the Sun, at 153,454 miles per hour, or 246,960 kilometers per hour. Helios A and Helios B, also known as Helios 1 and Helios 2, are a pair of probes launched into heliocentric orbit for the purpose of studying solar processes. A joint venture of West Germany's space agency and NASA, the probes were launched from Cape Canaveral, Florida, on December 10 in 1974, and January 15 in 1976 respectively. Built by Messerschmitt Kaugblom as the main contractor, they were the first space probes built outside the United States or Soviet Union. The probes are notable for having set a maximum speed record, among spacecraft at 252,792 km per hour. Helios 2 flew 3 million kilometers closer to the Sun than Helios 1, achieving perihelion on April 17, 1976 at a record distance of 0.29 astronomical unit, or 43.432 million kilometers, slightly inside the orbit of Mercury. Helios 2 was sent into orbit 13 months after the launch of Helios 1. The Helios space probes completed their primary missions by the early 1980s, but they continued to send data up to 1985. The probes are no longer functional, but still remain in their elliptical orbit around the Sun. Number 2. Juno Probe, maximum speed, 265,500 km per hour. Juno is the fastest spacecraft to enter orbit around another planet. But is it really the fastest spacecraft ever? When it comes to velocity, that depends on how you measure it. When the Juno spacecraft entered orbit around Jupiter on July 4 in 2016, it set all sorts of records: farthest operational solar-powered spacecraft, first spacecraft to enter polar orbit around another planet, first spacecraft with 3D printed parts, and first spacecraft with a titanium vault to offer protection from radiation. But did it also set a speed record? Yes or no? To tear free from the gravitational clutches of the Earth, a spacecraft needs to hit a bare minimum velocity, the escape velocity. This initial speed comes from a ferociously powerful launch. The New Horizons spacecraft holds the record for the fastest launch, but it didn't pull many tricks to pick up speed on its way to Pluto, and beyond into the Kuiper belt. At over 5 times the mass of New Horizons, Juno was going far slower when it was relinquished by its launch rocket. But the spacecraft added to that initial velocity by dipping back into Earth's gravitational well, stealing a bit of that potential energy for its journey, and boosting its speed by 7,300 meters per second. Closing in on Jupiter, Juno surrendered to the gas giant's gravitational pull, falling in until it reached a peak velocity of 57,900 meters per second, which means 130,000 miles per hour, by the time it started braking to make orbit. This made Juno the fastest object to ever enter orbit around another planet relative to Earth. Number 1. Parker Solar Probe. Maximum speed, 692,000 kilometers per hour. The Parker Solar Probe just earned the title of the fastest moving man-made object. Launched by NASA on August 12, 2018, this robotic spacecraft is currently very near to the Sun, on its way to probe the outer corona of our local star. According to NASA, its current speed is 153,545 miles per hour, or 68.6 kilometers per second. But really that just means super fast. It's nearly impossible to imagine something that fast, when the fastest man-made stuff on Earth is perhaps a railgun projectile at about 2.52 kilometers per second. That means the Parker Solar Probe is traveling at a speed that is 27 times faster than the fastest thing we've got down here. 2 years into its journey, Parker Solar Probe remains healthy and operating normally. Now, the probe will dip to within 0.1 astronomical units of the Sun's center. An astronomical unit is 93 million miles, the average distance between Earth and the Sun. At the closest approach, called perihelion, on September 27, the probe will come within about 8.4 million miles, or 13.5 million kilometers, of the Sun's surface. The probe is moving at 692,000 kilometers per hour. This was all about today's video. I hope you like it. Subscribe our channel for more videos like this. Thanks for watching.